All right, let's dive in. Today, we're talking about the real engines of the AI revolution. I mean, the actual hardware that gives AI its mind-blowing speed and power. So, let's get right to it.
I mean, think about it. AI is everywhere, right? It's completely transforming our world, from huge breakthroughs in medicine to the shows you and I binge watch every weekend.
But what's the secret sauce here? What's really going on under the hood that lets an AI learn and create? Well, it's not just about super smart code. It's about having the right kind of muscle to do the heavy lifting.
And that brings us to our first big topic, the AI power problem. See, the kind of deep learning that powers the AI we see today, it's a huge computational challenge. Our regular computers, they just weren't built for this kind of work. So, to really get why, let's talk about a computer's traditional brain, the CPU. Now, a CPU is a master at doing things one by one, sequentially. It's super fast at tackling one complex task at a time. But for the massive job of AI, that approach is like trying to build an entire skyscraper with just one person. It's just way too slow. Okay, here's a great way to think about it. The CPU, it's like one amazing, super efficient librarian, checking out books one by one by one. But at GPU, that's a whole different ballgame. It's like having a huge team of thousands of assistants, all checking out books for different people at the exact same time. Total game changer. And that army of assistants, that's the GPU, the graphics processing unit. What's so wild is that it's kind of an unlikely hero in this whole AI story. See, GPUs were never meant for AI. They were built for one thing, making our video games look absolutely stunning and realistic. So what's the magic trick here? It's something called parallel processing. Basically, the GPU can do thousands, even millions, of simple things all at once. That's what you need to render all those amazing 3D graphics in a game. And it just so happens, that's the exact same skill you need to train these giant AI models. So, why are they the perfect match? Well, a few big reasons. First, AI models are all about something called matrix operations. Just think of it as really complex math with huge grids of numbers. GPUs, they're absolute wizards at this stuff. Second, they've got thousands of little mini processors, or cores, that let them do all that work at once. And third, they just hit this perfect sweet spot of performance and cost. It's why a couple of big companies are really running the show in this space. Here's another great analogy. Imagine training an AI is like putting together a massive 1,000-piece puzzle. Your CPU would be there, carefully placing one single piece at a time. But the GPU, it's like having thousands of hands working on different sections of the puzzle all at once. I mean, you can just imagine how much faster that puzzle gets finished. Okay, so we've established that GPUs are the right tool for the job. But how do people, developers and companies, actually put them to work? How do you get from having the chip to running a powerful AI? Well, it really boils down to a three-step process. First, you've got to pick the right GPU. Then you need to get it talking to the right software. And finally, and this is super important, there's a way for pretty much anyone to tap into this power, even without buying a single piece of hardware. Now, this is the really crucial part. You need a translator. The hardware and the AI software don't speak the same language. That's where AI frameworks like TensorFlow and PyTorch come in. They're the bridge, the thing that lets the AI code tell the GPU exactly what to do, unleashing all that parallel processing power. But let's say you're a small startup. You've got a world-changing idea, but you don't have millions for a server room full of GPUs. What do? Well, this is where the cloud comes in. Services from AWS, Google, and Azure basically let you rent GPU power. You just pay for what you use, which has totally democratized the field and made cutting-edge AI accessible to almost everyone.
Okay, but the story doesn't stop with GPUs, not even close. They're definitely the big players on the field right now, but this whole area is moving at lightning speed, and we're starting to see new, even more specialized hardware pop up to handle very specific AI jobs. So let's do a quick rundown of the main players. You've got the GPU, which we can think of as a versatile, multi-purpose power tool. It can do a lot of things really well. Then you have Google's TPUs. These are more like precision instruments, custom-built just for the math that AI needs. Super efficient. And then there are FPGAs. Think of these as a customizable kitchen. You can literally rewire them for one specific recipe, making them perfect for really specialized, high-speed tasks. And if we really want to look ahead to the cutting edge, we've got something called neuromorphic computing. This is a whole new frontier.
We're talking about chips designed to actually mimic the structure of the human brain. The goal here is to get hardware that can learn more naturally, which could lead to unbelievable jumps in speed and, this is a big one, energy efficiency.
So, as we start to wrap this up, let's step back. What does all this mean for the future of intelligent machines? I mean, where is this crazy hardware race actually taking us?
All right, so what are the big takeaways here? First, GPUs are the workhorses right now. They're the backbone of this whole AI revolution. Second, specialized hardware like TPUs and FPGAs are finding their own important roles for specific jobs. And third, the real future is going to be about synergy, about using the right tool for the right part of the problem and making them all work together. And that leaves us with one last, really big question to chew on. As we go from hardware that's basically a super fast calculator to hardware that's literally inspired by our own brains, what will the AI of tomorrow actually think like?